Okay, this is Paul Gregg. I'm going to make another video documenting some backyard roller coaster work, and I call it the SpeediCoaster, and it's a deviation from a backyard roller coaster. It's a proposal for making a self-propelled roller coaster with hub motors on a one-person or two-person cart, and this would be for really rich people who wanted to experience much higher forces than a regular roller coaster, or for training of Air Force jet fighter pilots and astronauts. And I'll compare how that works. I have another presentation just for an Air Force jet pilot training roller coaster, but I'm not sure I'll make a video of that. I was holding this kind of close because I thought there was some commercial viability. But we'll go through it, and I'll try to stay on the things that are most interesting here. So back in 2021, um, I made a I started working on a new concept. I knew that backyard roller coaster and roller coasters in general, they're kind of fun, but they're very limited in what you can uh, experience. Some of them are, yeah, they experience high G's, 5 G's or more on the really severe ones. Typically, it's more like 3 G's. And they do lots of great things and simulate aircraft maneuvers, and there's experts in that who do a really good job of doing that, but they're very limited because they can't have more than, you have to design a roller coaster that anybody could ride on. It's kind of a wicked game they play with roller coasters, because there's some people in bad health who shouldn't be riding a roller coaster, and they have warnings about that. But you never know when someone's going to ride your roller coaster and come back with some kind of a medical issue. It's very difficult to keep within the constraints. If you had all young people under 25 years old, and you could design a roller coaster for them, you could make it have it a lot more accelerations. And so that's kind of this idea, bringing it down to a personal level where you could have a roller coaster only one person or two people ride at a time, which is economically not very good for an amusement industry, but it you could have a very select bunch of people who'd want to ride this thing and buy it. So this is the equation for optimum angle going around the curve of a roller coaster, and I use this in my little roller coasters, and it turned out really well. And then, so here's the deal. Here's the concept: is it's a one person roller coaster, maybe two, and it goes fast, but it has tight enough turns that the G forces are really high. Okay, up to like a fighter pilot kind of G's, above 9 G's and above, which is 9 times the weight of gravity, which, you can do that for so long and then you black out. But of course, a young person, a thrill seeker would be okay with doing that for a certain amount of time, especially if they could control the speed and either go really hard on it or go easier on it. And so this is my concept. We have one person roller coaster, maybe two single person roller coaster uh, um, carts on one track. It's powered by light batteries and hub motors in the wheels. And the idea is you just get to go on really fast. And there's an optimum speed for each banked corner. Okay. And if you're at the optimum speed, then the side wheels really don't do anything. Okay. There's no drag. But if you go a little slower than that or a little faster than that, then the side wheels engage to keep you on the track. And that provides some drag. And so it'd be kind of a game where you could have two of these guys on the same roller coaster, and the one who became within 10 feet of the other one was the winner. And it'd be really exciting. Um, so this is the concept: to make an interactive personal roller coaster which mostly stays near the ground. Don't have to have too much height and I don't have a lift hill because it's motorized with hub wheels, and that comes from modern skateboard electric skateboard technology. But I don't think it's ever been applied this way. There are slow versions of this, um, and I'll talk about that. High bank turns, small hills and overpasses, and the rider has control of the speed of the cart, okay, and braking. The same hub motors that provide your propulsion can also be used as brake, just like an electric car. Um, Now, this is the concept where you kind of competing or trying to get the best time on a certain track, and you could make multiple different tracks. Maybe in a place where, like Las Vegas, where there's lots of people seeking thrills, you could have a bunch of these tracks, and you could ride different ones, and there'd be speed records for each one. And if you go too fast, the side wheels engage and slow you down. If you go too slow, of course, you don't do well. So there's some super optimum uh, way of and leaning into the curve. There's a super optimum way of being the fastest person to go on that track. And it'd be really interesting to see people compete to see uh, who could go the fastest. Um, So the challenge is to go as fast as you can by any a combination of judging the optimum speed going into a bank turn, and then another bank turn the other way, and all kinds of different, just like any kind of roller coaster you want, um, and then maybe even some loops in it, and by leaning your body and controlling the speed and the braking, you could be the best on that track. It does have side and upstop wheels. It's impossible to leave the track, and if somebody does get lightheaded and starts to black out, then the thing automatically slows down, and they're not in danger. So this is an AI generated my first attempt at AI graphics, and yeah, it's a little weird, but that's the idea. Is you can go really fast, very high bank turns. The cart in my personal version of this idea. The cart has two or four or six or eight powered wheels with hub motors and an onboard light battery. And right now, I saw up to 8 kilowatt skateboards are available, and that seems like plenty. You don't have any steep hills it has to climb where it would slow down. You'd start it at ground level, and you just speed up as you go. Maybe you go around the track. Maybe it's a figure 8 track, and as you go around once, you're picking up speed, and by the second or third time, you're really a high speed optimum. Um, I'm not talking about super high speeds because you can control, there's two ways to control your accelerations on a roller coaster. The speed is one, but it's also the turn radius. So if you make small turn radiuses, you can have really high accelerations. And so it wouldn't be too expensive. You do have to have a track that allows maybe 30 miles an hour, 60 miles an hour, maybe 80 miles an hour. There's roller coasters nowadays that go 150 miles an hour or something like that. And so the track tolerances and the design of the wheels and the cart are really good enough to do that. And I think that's a if you look at the flight simulators, they were made when this technology wasn't available. And I think it needs to be revisited by um, people who are in charge of designing training for jet fighter pilots. You're trying to train them. You have two ways of doing it, either a screen-based flight simulator, and it may tilt back and do stuff like that. But that's really not that doesn't ever give you the correct accelerations for what's on the screen. And I'm sure many of you have been in a flight simulator like that, and it doesn't feel real. No matter what you do, it doesn't feel real. The other option is a centrifuge where a guy gets in a in a little box and he's spun around the room until he reaches 9 Gs. And the trouble with that is you only get one force. You don't get forces. You don't change forces quickly. And if he starts to block out, you just have to slow it down and get him out of there. So this one would have a lot better idea of matching your accelerations with your real motion. It's not controllable as far as I can, like an airplane, like a fighter pilot can turns his fighter any way he wants to. And so it's not totally controlled. You can control the speed, which is better than nothing, I guess. So here's some more requirements. Bank turns, you don't have to go too fast to get really high Gs. If you wanted to have high G's for a long period of time, then you could just do a spiral, and go around many times as you want, and it would feel just like a real fighter with the G's. So the features, it's much higher G's than a skateboard. Electric skateboard, you can only go so fast and turn so sharp on it, and then you just can't do it anymore. There's lots of accidents with electric skateboards, and there never would be with the SpeediCoaster because you're always safe. It have high bag turns, negative G's if you want to over small hills. Uh, You could have two cars on the same, yeah, like I said, some kind of a competition where if one car catches the other, then that's the winner. Advantage is you can safely experience much higher G forces than skateboarding or a conventional roller coaster. Riders can choose their experience somewhat by controlling the speed. No real high structure, so it's easier to build it, the roller coaster and to modify it. Uh, no need for um any high elevation for it. Low maintenance compared to a chain lift, but you know, uh, it's not going to have a high rider rate. And so it's a whole different thing than a conventional roller coaster. Um, yeah, if somebody starts to black out, then it senses that, or they take their foot off the pedal and it slows down and it's safe. So I'm going to go through this pretty quick because it's that's the basic concept. But the idea is you'd replace the lift system or the acceleration system of your roller coaster with hub wheels that are riding on the track, and probably a metal wheel with some kind of neoprene rim on it, just like real roller coaster wheels. Single rider concerns, commercially viable, small ride rate. Yeah, it's not for an amusement park. It's for someone who really wants to experience much higher G's than a normal roller coaster. Um, you're going to sell it to rich people if you're going to market it. Regenerative braking. Are the accelerations too high? They have to be managed by design. Um, so I thought a lot of names like that, and finally I call it a speedy coaster. This is a bunch of references, links to electric skateboards. This is the 149 mile an hour roller coaster made by Intamin in the Middle East. And so this is one of my carts, but I just modify it by putting hub motors on the back of it. This is one of my PVC roller coasters, obviously very slow by comparison, but you can get 3 Gs here. So horizontal bank turn. This is the simple equation. If you want high G's, this is how you get it. If I'm only going 30 miles an hour, if I go through a curve with a radius of 3 meters, just under 10 feet, I can get 6.1 G's. That's higher than any roller coaster in the world. Um, and so it's not that difficult to get really high G's. This is the optimum bank angle. This is what you do over a bump if you want a little bit of air times, negative G's and stuff like that. Um, And then I go through a bunch of technical stuff about how much I would. This is not my forte, the electrical part of it. So we need to bring on someone on board if we were going to do this commercially. This is a standard electric skateboard. They go really well, 20 miles an hour, and about $600, something like that. I'm saying just take the hub motors off of that and put them on a roller coaster. That's really my idea. There's some hub motors on eBay or AliExpress. They're not that much. So, you could have just as simple to start out. And for prototyping, you could just say, look, I put the bank turns in there. How fast can I go around here? What the radius is and try it out. Then do a figure eight, then do then just there's endless concepts of roller coasters that you could come up with. And, uh, and you can even have add-ons or something like that. So, There is a company in Germany that makes an alpine coaster. It has kind of a rubber wheel on the bottom that accelerates it and decelerates it, but they're not really using hub motors, I believe. And it only goes 25 miles an hour because it's sold to the public, and you can't have anything very dangerous that's going to be in the hands of the public, the general public. So this is what I would need to start this, and I'm not going to do it. So I'm just putting it out there for anybody who wants to. Is you need someone to design the track, a really good track designer that with high-end analysis, dynamic analysis methods, and then really the rolling of the tube and the welding, or however you're going to make the track, whether you make it in box or whatever form you make it, it has to be very high, fairly high good tolerances, which, that technology is available in certain companies and they guard those secrets very well. And then get the battery and motor expertise. And then, let's see. Why isn't it done before? The economics just aren't there for a commercial uh, amusement park. Single rider, two riders, you're never going to make a lot of throughput there. And so it's economically not suitable to that. But for a rich guy who wants one in his backyard or the Air Force who wants to train fighter pilots in it, yeah, they could afford that. Yeah, I'm thinking this could be used to train pilots. Um, and I think when I don't know, maybe somebody in the Air Force thought about doing this one time, but they didn't have the tolerances. When they made these decisions, they couldn't make roller coasters to the tolerances you need. And primary advantage over centrifugal simulators, it can apply very rapid, realistic changes in pilot accelerator. I turn left, turn to the right, go up, do negative G's, positive G's in a loop, and do this stuff. Centrifuge can't do that. It only does one thing. Um, and you could simulate fighter jet maneuvers, you know, and fighter jets take a great big, long time to turn, but you're doing it in very short radii compared to fighters, and so you can get the same effect. Here's that same calculation. 30 miles an hour, I can get 61 Gs. Now this is what a real fighter does. This is the F-15, F-16, F-14, and they turn. You can see their turn radiuses are really big. Okay, and they don't turn that fast. I mean, when a fighter pilot says I can turn fast, he's talking about I can turn 180 degrees in 10 seconds or something. Uh, he can do 14 degrees a second. And so um, with a track, you can apply much higher forces than that, and you can turn in a much smaller radius. So, and you can figure that out. So here's a table I made. If the SpeediCoaster, for this is more for pilot training for high Gs. If you're going 60 miles an hour, it's pretty easy to get 9 Gs. You just have to have a 8 meter turn radius, and you've got 9 Gs. And your bank angle is 84 degrees, a really high bank angle. And so, you look at this, even at 30 degrees, yeah, I can get 9 Gs by doing a 2 meter turn radius, which is a very small radius, but it's still, I could do a turn. Let's say I was going 60 miles an hour and I wanted 6 Gs and I wanted it for a long time. Okay, I wanted it for 5 seconds. Well, 180 degrees is only 1.4 seconds. So 2.8 seconds give me a full circle, 360 degrees. And if I wanted to do that uh, for 5 seconds, I would have to do some kind of spiral, and but I could still do it. I could make it feel exactly like a fighter doing a 6G maneuver for 10 seconds. So I think its usefulness as a uh, pilot training, I think it far exceeds screen-based flight fit simulators, and uh, and it's more versatile than a centrifugal. It's kind of the sweet spot in the middle of those two worlds, and I think it would really do well. So I sent some letters out, and we'll see if I get any response from the roller coaster companies or the Air Force or DARPA or somebody who wants to have a roller coaster that could be suitable for training fighter pilots, or for some real thrill seekers who want to do it in their backyard or at a special facility. And that's my idea. Thanks for watching, and I'll see you later.